define with parentheses after it is an abbreviation. So define foo A, B, C body is actually an abbreviation for define foo lambda of ABC body. So define, if its first argument is something in parentheses, pulls out the first word, says, OK, that's the symbol that I'm defining. And then the rest of the parentheses is the formal parameters for the function. And we use lambda to create a function with these formal parameters in this body. OK? So if you sort of, whenever you see something like this, just remember that it's a convenience, and really define only does one thing, which is take a name and a value and associate that name with that value. And it's lambda that does the creation of procedures, and we just sort of hid the lambda here. This, by the way, is the Greek letter lambda. That's how I write it on the chalkboard. You, of course, write L-A-M-B-D-A because your keyboards don't have lambdas on them. Yeah? If I put parentheses around, if you put parentheses here, it says this is an abbreviation for a lambda. So let me not do it here. Let me do it on another board. OK, so this abbreviates, of course, define foo. And then comes a lambda with all the formal parameters of foo. Namely, there aren't any. So it's lambda of no arguments. And then the body is this whole lambda expression. OK? So what we're defining here is a procedure of no arguments that returns a procedure. OK? This example seems particularly useless. And it is pretty useless because it's, this example was useless too. But writing procedures that return procedures is not useless at all. We're going to do that in just a moment. Other questions before I do? OK. So I want to teach you the idea of first-class data. This is a key idea in programming language design. So one of the things that you might have in the back of your head throughout this whole class is, how come there are hundreds of programming languages that people are using one way or another? Why haven't they figured out the best one yet and settled on that? And the answer is that different language designers have different ideas about what's best and what goals they're trying to achieve. And all of those languages have little niches that they fit in. But at least one way of looking at programming language design puts an emphasis on first-class data. That means anything that's in the language at all ought to be just as good as anything else. Okay? So think about the role of numbers in whatever programming language you grew up in. A number can be the value of a variable. A number can be an argument to a procedure. A number can be the return value from a procedure. A number can be a member of a data aggregate. That means something like an array or a list. We haven't really gotten to full-fledged data aggregates yet. That's chapter 2 in a couple of weeks. But you'll see that this holds true for us also once we get there. So numbers are first class, I think, in every single programming language there's ever been. Text strings tend to be first class in most languages today. Although once upon a time, it was only individual text characters that were first class. But now you can have, procedure that takes a text string as an argument and returns some subset of that text string based on some criterion or other. That's a common standard thing to do. Procedures typically are not first class. In most programming languages, you can't do these things to a procedure. Some languages, like the ones in the C family, C and C++ and Java and those guys, let you do something that's almost the same but not quite, which is you can have a pointer to a procedure as an argument to something. So pointers to procedures can be the value of a variable, argument, return value, member, data, aggregate. That's all true. But a pointer to a procedure isn't the same thing as a procedure. And in just a moment, I'm going to show you the sort of thing that we can do with first-class procedures that those languages can't do, at least not without standing on your head. But procedures are just sort of one example, the most important example, of things, everything should be first class. Everything in your language should be first class. If you have a language, for example, that lets you put up windows and drag them around, then a window should be able to be the value of a variable, an argument to a procedure, et cetera. Okay? If it's in the language, you ought to be able to manipulate it. That's the idea of first-classness, as opposed to second-class data, which you can't really do that to. So here's the classic first example of procedures that return procedures. Because we talked about being the value of a variable. That's what that abbreviation business is about. So the procedure foo is really the value of the variable foo. Procedures can be arguments to procedures, as in the case of keep. And we're about to talk about procedures as return values from procedures. So here's a procedure called makeAdder. Its domain is numbers. Its range is procedures. So it takes in a number as argument, and it returns a procedure. So I can say, for example, define 3 plus. Notice that there's no parentheses around that word. makeAdder 3. Now I can say, 3 plus 9 and get 12. Okay? So define, let's define up here. This is not the one with the abbreviation built in. It's not define open parenthesis 3 plus anything. This just says make a binding, an association between the name 3 plus and whatever the value of this expression turns out to be. So define evaluates this expression, and whatever the value it gets back, that's what it makes have the name 3 plus. But that turns out in this case to be a procedure. What you get back from makeAdder is a function. It's the function lambda x plus x3. Because when we call makeAdder with 3, as I'm doing where the cursor is blinking, we substitute the actual argument value, 3, for the formal parameter, num, in the body of makeAdder. The body of makeAdder is this lambda expression. So after substituting 3 for num, we get lambda x plus x3, which is indeed what 3 plus ought to do. Isn't that cool? So I can put it in a variable. I can do this. No. Make adder 720. So here I never gave the function a name. It's just an anonymous function, lambda x plus x 7. And I applied that to 20, and I got 27. Questions about this example? So you get the point that it's a cool thing that you couldn't do in your high school programming language, because in some program like C, in some language like C or Java or whatever, if you already had a procedure named 3+, then you could return a pointer to it as the value from some other procedure, but you would have to have explicitly written a procedure 3+. You can't just make up procedures on the fly in most languages, and that's what we're doing here. You call makeAdder, it creates a procedure that didn't exist until you called makeAdder. Yeah?
Why don't all languages treat procedures as first-class data?
Right. Why don't all languages treat procedures as first-class data? I didn't pay him to ask that. I have two answers to that. One is, it turns out to be a little bit costly in the implementation for reasons that we'll get to around chapter 4. Well, a little bit chapter 3. And so they don't want to do it because it's costly. The other reason is they've never heard of it. A lot of programming languages get designed by people who are not programming language experts. And they tend to lack some advanced capabilities. Anyway, don't get me started on the stupidity of other languages. But all the cool languages can do it.